torque. Expression for torque. This is x-axis, this is y-axis, this is a point mass, this is R, this is force applied, this is angle phi with R. This is origin of coordinate system. Then the rotation about O is in this direction. Torque. When a body rotates about any point, then there will be what? Torque. The expression is this RF sin phi. Derivation not required. When we drive, this will be torque, where tau is torque, R distance of object from point of rotation. Phi angle between force and position vector. So this is expression. Direction of torque. Torque R cross F. This is again expression. Where sin phi is there, it is in cross. So the torque is perpendicular to R. Torque is perpendicular to F. Why? Cross. Cross is there. So torque is cross to R, cross to F, perpendicular to R, perpendicular. This is what direction. And outside plane of board. Why? Yeah, this is right hand screw rule. If motion of particle is clockwise, then direction is inside. What is this? Right hand screw rule. It is moving like this. Anti-clock. Direction is out. If it will move in clock, then. So this is the direction of torque. Special cases. First, if phi is 0, then tau RF sin phi RF sin 0, torque is 0. If phi is 90, Then torque RF sine 90. Torque is RF. This is definition of torque. Phi 90. This is direction of force, then phi will be what? 90. This is direction. So R becomes perpendicular distance of object from point of rotation. If this is the expression, then R becomes perpendicular distance. When R becomes perpendicular distance, it is called moment of force. So this is definition. Moment of force called torque. That is, it is denoted by tau, and tau is RL, where R is perpendicular distance of force from point of rotation. ये फोर्स ये ऐसे लगा दे phi 90, then torque comes out to be this. This is definition. Units SI. Force Newton R meter. CGS dyne watt centimeter. Dimensions force, this is force RL. So dimensions of torque are as that of work, energy. So this is something about torque. So it is what? Rotational effect of force. Angular momentum. Expression. This is x-axis. This is origin of coordinate system, y-axis. This is some mass. This is position vector. Here this is force. So this is what? linear momentum, and this is rotation about O. This is direction of force, so this will be direction of momentum, and it is rotating by this force. फोर्स की कोई भी डायरेक्शन हो सकती है, डिस्प्लेसमेंट किसी में भी, तो दिस इज मोशन. रोटेशनल मोशन की बातें हैं ये, एंगुलर मोमेंटम, टॉर्क, मोमेंट ऑफ इनर्शिया. एक्सप्रेशन L RP sin phi, derivation not required. Or L R cross P. Direction. Here. L perpendicular to R, L perpendicular to P, and outside plane of both. Where what is P? Linear momentum. What is L? Angular momentum. What is R? Distance of object from point of rotation. Special cases. This was phi. First, phi 0, L RP sin phi, RP sin 0, it is 0. Phi 90, L RP sin 90, it is RP. Now what R becomes? If phi is 90, perpendicular distance है ये, किसका? फोर्स का, लीनियर मोमेंटम का, फ्रॉम पॉइंट ऑफ रोटेशन. तो कहाँ क्या निकला इससे? डेफिनेशन ऑफ एंगुलर मोमेंटम. This is what now, if it is perpendicular distance, we say it is moment of what? Momentum called angular momentum. It is denoted by capital L, and capital L is RP, where R perpendicular distance of force from point of rotation. Units. SI, rough work, LRP, RMV, M, kg, meter per second velocity, R, meter, SI unit, kilogram meter square second inverse, CGS, gram centimeter square second inverse. Dimensions, LRP, R, L, P, M, V, so it is what? M L square T minus 1 V L T minus 1. So this is what? M L square T minus 1. This is what? Units of angular momentum. Moment of inertia. This is expression, derivation not required. This is point of rotation. This is point mass. And this is rotating like this. So this will be what? Moment of inertia. Product of M मास किसका? ऑफ पॉइंट मास एंड स्क्वायर ऑफ डिस्टेंस ऑफ पॉइंट मास फ्रॉम axis of rotation called moment of inertia. Units SI kilogram, R square meter square, CGS gram centimeter square. Dimensions M L square, time, no time. These are the dimensions. Torque is scalar or vector Y. This is a question. We know torque R cross F. This was expression as torque is cross product of two vectors. So it is vector quantity. Angular momentum is scalar or vector. Now this is the question. Momentum we know L R cross P. What was L? RP sine phi. So R cross P as L. L is what? Angular momentum is cross product. क्रॉस प्रोडक्ट क्या होती है? वेक्टर प्रोडक्ट बोलते हैं. वेक्टर किसकी है क्रॉस? टू वेक्टर्स. टू वेक्टर्स क्रॉस ये बताएगा. यदि डॉट होता टू वेक्टर स्केलर होती. क्रॉस सो it is vector quantity. PMV linear momentum. P in rotational it becomes L. M-I-V omega. F MA. So we have said in dimension F rotational torque I, this one, F dp by dt Newton's second law. So F dp dl by dt. Now we will derive these things. वहाँ डायमेंशन में क्या कर दिया? इस जैसा ये, इस जैसा ये. Now we will derive them. First, derive torque I alpha. Tau is torque I is moment of inertia. Alpha angular acceleration. We know torque RF. This was a definition. F MA. R is R, M. F is MA. R is R, M is MA. We have already read arc upon radius is theta. Differentiate or by t, V r omega by t, A r alpha. A is R alpha. It is mr square alpha. But what is mr square? It was I, moment of inertia. I alpha, hence derived. Derived. L, this one. I omega. L angular momentum. I moment of inertia. Omega angular velocity. We know L, it is RP. Definition, moment of momentum is angular momentum. LRP, P is MV. LRMV, this is V. R omega. ये कहाँ से आए थे? आर्क अपॉन रेडियस थीटा, सो एस इज आर थीटा. Either differentiate or divide by time. V r omega again, differentiate or divide by time. It is L. mr square omega L. mr square is I omega. Because I is mr square, hence derived. This one. Derived tau dl by dt. First find L, then differentiate. Find L. This is L. Definition of L. This is L. Now d by dt. You will get the desired result. We know L RP, L PMV, RMV, R omega, or it is mr square omega, or L is I omega. We have already done differentiating it with respect to time. D dt L, M constant, d dt of omega, or dl by dt is I alpha. Why? Alpha is d omega by dt, or dl by dt is tau. Why? Because tau is I alpha. So this is derived torque I alpha, angular momentum I omega, tau dl by dt. Law of conservation of angular momentum. This is a question. Statement. In absence of external torque, total angular momentum of system is constant or conserved or remain same. कहाँ से दी डेफिनेशन? ये वही लॉ ऑफ कंजर्वेशन ऑफ लीनियर मोमेंटम. In absence of external force, total linear momentum of system is constant, conserved. In absence linear momentum वहाँ से दी. We have read in metric up to metric. So instead of force, here in absence of external torque, total angular momentum of system is constant, conserved, remains same. We know torque dl by dt. If tau is 0, then Put here dl by dt is 0. Integrating it, that is L. इसका इंटीग्रेशन L and its is constant. dt इधर ले जाओ 0, dl का क्या हो जाएगा L, 0 का क्या होगा constant. That is, if tau is 0, L is constant. So this is what law of conservation of angular momentum. L is I omega is constant. If I 100 omega 10, say value of constant is 1000. If it becomes 10, the constant remains 1000. The angular velocity will increase. If I becomes 1, because the value of constant will not change, rough work, L constant in absence of axial torque. And what was L? I omega. This means if I decreases, omega will increase so that their product remains constant. So, a question. Planets close to sun move fast. Why? This is a question. तो हाउ टू आंसर, ये चेक करो. क्लोजर में डिस्टेंस क्या होगा, आई क्या होगा. When planet is close to sun, its distance decreases. So क्लोज है तो डिस्टेंस कम होगा तो I. So I, moment of inertia decreases. Why? I m r square. Now if this decreases, what happens? Omega. Hence angular speed increases. Why? I omega constant. Planets similarly away from sun move slow. When they are away, this increases. So I Again, planets close to sun, distance decreases, moment of inertia decreases, angular speed increases. Planets away from sun, R increases. If the question is there, R increases, so moment of inertia increases. This goes on increasing, so angular speed decreases. So planets away from sun move slow. Why? Another question. A dancing girl closes her hands and feet while dancing. Why? When she closes her hands and feet, radius of rotation decreases. So, moment of inertia decreases. R decreases. एक बार ऐसे हैंड्स हैं तो दिस इज आर फ्रॉम हियर टू हियर. नाउ शी क्लोजेस तो दिस इज व्हाट आर हैंड्स. ये डिक्रीज हो रहा है तो व्हाट हैपेंस? ओमेगा इंक्रीजेस. हैंड्स angular speed increases. Why? Because I omega constant. So she closes her hands and feet to dance fast.